Hello again, everyone. Today's topic is partitioning a line segment. What partitioning means is we're going to find a point on a line that's going to split up our line into a certain ratio. Okay? So, this particular example tells us that we're going to be partitioning line segment AB, where A is at -7, 7, and B is located at 14, -7. And we want to place point P so that we're breaking the line up into a ratio of 3 to 4, meaning that whatever distance is on this side, if we were to consider it to be 3 units compared to 4 units on the other side. Okay, that's what partitioning means. We want to break it up into not equal, but we want to break it up into pieces that match that ratio. So first of all, we've got to plot A and B. -7, 7 is up here. That's A. And 14, -7 is right here. So that's B. Now, let's connect these points so we can see exactly what we're working with. So what my goal is I'm going to be putting a point P somewhere so that when I count units over here, I'm only going to have 3 compared to 4 on this side. So it's not going to be in the middle. It's going to be a little bit more on this side of the line. Well, there's a couple of ways that you can go about doing this. There's definitely some very difficult methods out there. The method that we're going to be using is going to work for this particular class. What we're going to do is we're going to look at this as a right triangle. So the first thing I'm going to do is I'm going to draw in the sides to this. And I'm going to count how long each of these sides are. This side happens to be 14 long. From point A along this side of the triangle, this happens to be 14 units. And if I was to count all of these, I'm going to find that this happens to be 21 units long. Right, from 7 to 14, 7 and 14 gives you 21. Now, my ratio is a 3 to 4 ratio. That means for every 3 units I go, I need to go 4 units on the other side. So I have a total here of 7 units. Okay? Now, if I was to multiply this with a scale factor of 2, I would end up getting 6 to 8 units. For every 6, I get 8 on the other side. That gives me a total of 14. That 14 is actually coming into play because I can count these units. So I want to count 6 units from A. 1, 2, 3, 4, 5, 6. And if I was to count the remainder here, I would notice that I actually have 8 units on this bottom piece. So it has been broken up into the proper ratio. However, it's not on the line that we're looking for yet. This down here we already recognize as being 21 units. Well, let's keep on going. If I change this ratio from 3 to 4, if I multiply it by a scale factor of 3, I'm going to end up getting 9 over 12. Well, 9 plus 12 gives me a total of 21, which matches with this bottom piece of my triangle. So I want to cut 21 into a ratio of 9 to 12. So I'm going to count over 9, 2, 3, 4, 5, 6, 7, 8, 9. And if we were to check the other side, this other side has a ratio of 12. Well, again, I've only split them up on these lines. We want to know on this line. Well, lucky for us, if we follow them along to wherever it hits the line, we're going to find that that is exactly where our point P should fall. So the location for P right now is at, let's see, 1, 2, and up 1 from the origin. So that's our solution. That's where we want to put point P. Now, I'm going to show you exactly what's happening here. We can actually kind of see it, that we're going over 3 and down 2, and we can notice that if we were to chop this piece of line up, we actually have 1, 2, 3, 4, 5, 6, 7 pieces, and we notice that we have 1, 2, 3 on this side, and we have 1, 2, 3, 4 on this side. So we've actually put point P exactly 3 to 4 full units, which is exactly what we were hoping for. Okay, so I've shown you on the sides what's going on, and I've shown you on the actual line what's going on. So I want you to try this next one on your own. This last step in blue is not necessary. The red steps definitely are, though. So try partitioning this line on your own. You're going to need some graph paper and a couple of seconds of this video paused. Alright, let's see how you did. First thing we're going to have to do is plot points A and B. So A is at -5, 4, and B is at 10, -6. I'm going to connect my points. And then I'm going to real quickly draw in the triangle. That triangle is necessary to work with because it's going to make our counting part of this problem way easier. So if I count this side, this is 4, and 6 gives me a length of 10. 5 and 10 gives me a length of 15. And when I start looking at my ratio of 1 to 4, 1 to 4 gives me a total of 5. When I double this, I'm going to have 2 to 8, which gives me a total of 10, which is what we're looking for. And if I triple this, we're going to have 3 to 12, which gives me a total of 15. So these are the ratios that I can use to give me a total length of 10 and total length of 15. I want to use these. Now remember, I'm going from A to B. So I'm going to start at A and I'm going to count down 2 units. 2 compared to 8 gives me a total of 10. So this is the length downward from A that I need to go. I'm also going to be going over in this direction towards B. So when I count over here, I want to count over 3 units compared to 12 to keep that ratio going. So here's 3. This other side takes up 12, but I'm concerned with where these two meet, which happens to be right here. Okay, so my point P that I'm going to place on this line AB happens to be -2, 2. That's the solution to this problem. Hopefully you got that. That's really how difficult these problems are going to get for our class. So if you have any questions, please let me know on either the website or in class. See you later.